Hey guys, we're headed to the west side today. We're going to install a VFD for a well pump. Currently the well pump's running across the line on a motor starter, and we're going to upgrade it to a VFD to give the customer better control and monitoring. Should be pretty easy. We got Tellus riding along as well, so we should have a good time. Might be even a little bit of fun. Alright, we'll see you there. Here's our existing across the line starter. Should fit. Here's our supply panel. Power comes up through that gutter and down, and here's our load out to the well. Okay, we got the old starter off the wall and all the old wiring disconnected. Okay, so we're going to come out of the existing hole in the gutter there, come straight down into a new junction box down low that's going to be sitting on the conduit that feeds the motor. Then out of that box it'll come up into our drive, which will be somewhere in about that region there. And then I've laid it out on the ground here. Here's where our conduit into the slab is going for the motor, and then our supply power in, and our power to the drive, and our load out of the drive. And I mocked it up. These are going to be about 12 inches separate, and it's just a slight offset there. It's so small I'm going to attempt to do it with just heating PVC. Here's our old panel board we got to replace. This guy's seen better days. And I'll show you the burnt damage to the bussing on the inside here. So here you can see where a breaker was connected on the left-hand side here. A lot of heat damage. Looks like they were able to get the old breaker out, but that mounting screw for the breaker is just arced right onto there. So nothing's landed there now, but this panel's ready to be replaced just with that damage in there. And we got Telly making our holes in our JB. Okay, we got our drive up. Just need to get these offsets in the bottom here. Pretty tight fit, about 13-inch run. We'll see if I can do it with a torch. All right, there's our offset PVC pieces. I've done worse. I'm happy with that. Now we just need to wire it. We're going to use the existing wire in the gutter. We'll splice on there, bring down in that conduit into our line side of the drive on the left. Then we'll bring our motor connection up onto the load side, and we'll need to extend our control wiring. These smaller 18 gauge wires we'll splice onto them, extend them down through the gutter and up into the drive onto the control terminals up here. Tully's up here putting together the splices. It's a very simple application for the drive. We're just starting and stopping a well pump. So we know we have overload, run feedback, call are the main ones we need. We don't really need the third voltage okay. So let's just start with call, which is our pair of blues. The way this drive works, it's got a source 24 volt voltage there on terminal 10. You're gonna put one blue there, and then we're gonna make digital input number 1 start. So you'll put one blue on 24 volts and the other blue on DI1. Let me just get a close up of 24 volts and DI1. And you can see how little you need to strip there. You don't have to strip very much. We don't want a lot of copper showing.
Oh yeah, I've been working on control panels.
Very good. And this is essentially a control panel just within the drive. So like, here's all our power wiring down here, and here's all our control wiring, and you would do it just like you would a control panel, kind of tidy. You can have little loops, and we'll use zip ties to clean it up.
It was 13V1, DI1.
DI1. Yeah, digital input 1 is what you want. And we'll configure that. I'm pretty certain that that comes as the default start-stop, but we'll set that up when we fire it up. And the nice thing about these drives is everything's configurable. So if we do put something in the wrong place, we can totally change it later. Good? Looks good. Great. So now we've got relay outputs here on the side. These we can have the drive activate and change state dependent on any kind of condition that is present within the drive. The two that we're going to use is overload, or what we're going to call fault now, because all we had on the other contactor was just an overload. And we're also going to use running. So let's put running yellow, our pairs of yellows, onto relay output 1, okay? And what you're gonna do, you're gonna put, here's your common C, our relay output 1 C. Yep. And then I want it on the normally open D.
C.
C and B for yellows.
And over here.
Yeah, you can kind of bring it like that. You know, we don't want to go too wide out here. We're going to end up tucking it in. There's that little wire there. And if, you know, as long as you leave slack, we can fold them in wherever we want. And the cover is just going to come tight like that. So if we have to like coil them up here, we can. And that's our 2 relay outputs, really. It's really simple setup. So you put run onto relay output 1 and overload onto relay output 2. Let's put our purples onto relay output 3. And previously they were on a 777 motor saver, just changing state when the voltage went out of bounds. We'll see if there's a fault or something we can assign to relay output 3 that matches that same description. Okay, we're ready to power it up. Go. All right, so when these ACS-580s first wake up, they say, hey, startup assistant, don't show it power up or not now. Basically, it has a wizard that'll help you set up all your parameters. Let's go ahead and do that. So hit next.
This one?
Mm-hmm. And we want US standard, that's good, next. Now, be real careful with your thumb presses here, so make sure you know what you're doing. You don't want to accidentally press anything, so just be real deliberate. So it's loading. Right now, the drive has a brain and a computer in it, and so does this touchpad, and so it's loading that from the drive is what it's saying. Okay, so we've picked American units. So just scroll down. Horsepower, Fahrenheit, foot pounds, dollars. I don't know why it needs dollars. That all looks good to me. Hit next. Date and time.
48.
Yep. Perfect. So the date's good. Month, day, year works for me. Show time is 12 hour. That works for me. And if there was more to this menu, there'd be a scroll wheel on the side there. So you can hit next. Naming the drive, ACS-580. Let's name it. Hit the right arrow. And then I want you to change the name to Well 1. So you need to back up. Let's get rid of all that. And then you pick a letter, and then you hit next. Okay? Does that make sense?
Yeah.
Cool. So go ahead and make that Well 1. Name is just put across the top of the HMI. So it's just a local name for users who are standing here. Go ahead and hit save. And see, now it says Well 1 at the top instead of ACS-580. This name will show at the top of the, making it easier to see which motor. Yep, next. Perfect. Find the values on the motor nameplate and enter them here.
It's the right voltage, yeah.
Yeah, we're an asynchronous motor. We want, so the current you need to change that current to 67.
Okay.
Good. And the voltage can stay at 230, that's good. Frequency is good at 60 hertz. Speed, hold on a second, let's check the nameplate for that. The hertz, or the speed is 3450. RPM, yep. 3450. Don't worry about cosine, keep going. Torque optional, we don't need that. Control mode scalar is fine. Okay, then hit next. Direction test. Spin the motor to check direction. Not now. So this would be, hold on, this would be if we had the motor up here visible to us. But since we can't see it, we're going to do a full speed rotation check in a moment here, and we're going to look for flow here at the surface. But if we had the motor just sitting off to the side someplace here, we could do a check where it would spin it very slowly, and we could look at the rotation. So we're going to say not now next. Yeah. Make backup. Copies all settings into a backup file stored. Not now. We don't need to worry about that. First start is complete. Drive is ready for use. So here's the default settings it comes with. Start and stop is digital input 1. Just like we wired it, digital input 1. And its reference for frequency is analog input 1 scaled. We're going to get rid of that to make it run normally. So you can hit done. Now go into options, and we need to set the reference menu. Then go primary settings, and then start stop reference and reference from. So that's where it's getting its idea of what speed it needs. So I want it to reference from, hold on. Yeah, we want it to reference not from analog input 1 directly. We want it to reference from the control panel. Let's try that. I believe control panel means this. Very good. So now it's going to start and stop from digital input 1. Doesn't have a secondary control location, doesn't have any run permissions. So now let's look at ramps. That's the next one down. Okay, acceleration time 20 seconds. That's a little long. Let's lower our acceleration time to 5 seconds. Good. And then I want our deceleration time. I want that to be 10 seconds. Good. Frequency scaling, that all looks good. Stop mode, go there. We need to change that to ramp. Otherwise, coast just means remove power. Okay. So if we're in coast, it's just going to remove power, and the water is just going to keep going and then slam back.
The whole point we have this is to
ramp down. Yep. It'll ramp up, and we don't need to use 2 ramp sets. Why is that? It's where DI5 would activate the second ramp set. We'll just ignore that. That's fine. You can go back. Yeah, go back. Okay, limits. We should have had this set up already. Minimum frequency, let's change that to 0 hertz.
How do I change the name?
Go 60 and go up. Yep, exactly.
0.
Yep, save. And maximum current, we're going to set that. What do we want to set our maximum current at? Let's do a 1.15 of 67, I believe was the nameplate amps. So 67 times 1.15. Let's do 77.5 for just 77. And then go maximum current and set that to 80. And we're going to tune that in as we see. Because in this application, we don't have the exact nameplate for the pump. If we did, we could copy those parameters right off, or for the motor, excuse me. We could copy those parameters right off of the motor nameplate. But here, we're using an existing motor that we don't have an accurate record, so we're kind of going to run it, see how it performs, and set up all our protections based on that. Just keep scanning. Advanced, no. I think we are good to go. You can hit back. Okay, and then, so now, all the way back out to the main menu, exit. Yep. Now try and hit up and down. There we go, raise that to 60 hertz. You can hold down the numbers, I think. The max it'll go should be 60. Good. So now our control thing is at 60. Now put it into remote. You see the lock remote button?
Yes.
That guy, press him. So now it's in remote control. Good. Because basically I want the speed to be controlled from here, but I want the starting and stopping to be remotely controlled. Because we're just transferring water into a tank, I don't need to feather or speed up or slow down the pump. I just need it to start and stop. Now we're going to set up all our relay outputs. That's an off. So go into menu. Because whatever the relay output for run is probably held closed right now. So we need to go into, you went into main menu, keep going down, input output, I/O. Yep, I/O. Okay, so digital input 1 is good. Keep going down. We're looking for RO. There's analog input RO1. Okay, so RO1, we set that up. Okay, yeah, so yellow is run feedback. So RO1 is not ready run. We want to change that to running. So go to source, and then
look for running.
Running. Good. So you hear that relay disengage. Now we want to, and then hit back, because we're going to change RO2. What color wires are on RO2? Brown?
Brown.
Yeah, so we want to change RO2 to fault. So we go down source. Let's see what all our choices are. Fault. Fault and -1. I forget which is which. Let's try fault. Save. And then back out. Pretty sure negative means it's true when there isn't a fault. But let's get out the meter and put it on continuity and check between A and C right there. It should be open is what we want.
On R2?
R2, A, and C. Yep. It's open to me. It's not beeping, so we're good. Okay, so that's RO2 is ready. And then 3 we put as our voltage okay. Let's see what we've got for choices for RO3. Maybe there's some, yeah, so let's change RO3. Go to source. Let's do ready run. And then back. Cool. Okay, we're ready for test number 1. We're gonna put the well in hand. 3, 2, 1. Beautiful. Okay, Hertz is climbing, amps is climbing. Current's a little higher than I thought it would be. Sitting around 80. We'll wait for our flow to show up. And so it's not going to go any higher than that because we set up our current limit as 80. Now, it could be it's spinning the wrong direction. Usually it doesn't take very long for that water to get here. Good ramp, good decel. Yeah. So we'll give it a 20-minute cool down and then we'll change the rotation. All right, so we've changed the rotation on the load side here. We previously were black, red, blue, and we weren't getting any water at the surface, so now we're red, black, blue. So we should be spinning the correct direction. Go ahead and put well pump in hand. There it goes, ramping up. I heard water hit out there, that's a good sign. Our flow is climbing, 150, 200 GPM almost. We're sitting at about 80 amps, or 60 Hertz. It's looking good. 285 GPM, climbing. Let's put it down. Okay, so we're right there at 80 amps. Hard to tell if that's high or what. Our GPM is 297, so that's pretty good.
That's what our limit is at.
Yeah, I almost want to raise our limit and see what it does. Yeah, I wonder if we can do that live. Some parameters, they don't let you change them. Wow. Go into here, parameters, modified, and that'll show you everything that you've changed. That way you don't have to hunt it down. Maximum current. Let's kick that up to 85 and see what happens, if they'll let us do it. Yep, that's good. So now we're at full speed and it just wants to be a hair above 80. So that's not too bad. I like that. Now, I'm curious if it's going to overload because our motor rated current is much lower than that. Yeah, our motor nominal current is 67. Very low. Because we're going off a guess off of a nameplate. You see how the torque is really high because it's higher than what it should be? Yeah, it's hard to really tell what our amps are. Let's just let it run for a minute and see what it does. But here's a nice healthy run. We're at full speed, 80.6 amps. And about 300 GPM. Okay, now we're going to do a shutdown and watch it ramp down. Should be a 10-second deceleration. There it goes. Beautiful. Cool. And then we'll do our cycle stop and test it again. Let's go ahead and put it in hand. I want to see it run and ramp one more time before we walk away.
Okay.
And awesome. There it goes, ramping up. Try to lower our speed just a little bit. See, if we go 59 Hertz, now we're near where it was this morning at about 75 amps. The BPM is about the same. That's even a little too low. What's our BPM now? Yeah. How about now? That's our good.
285.
You feel like you learned anything about drives?
I think so.
Like what?
I learned a lot more about the parameters, how to set them and change them and navigating the menu.
These ABB drives are really nice because everything's in English. It's not a bunch of parameter numbers like P71 equals 7.2. It actually tells you motor torque and everything's in English and very easy. You don't even really need a manual as long as you understand the principle that you're trying to accomplish. Cool. Good job.